Welcome. In this lecture, I want to talk about Cartesian products, which are something that you've actually seen before, you just didn't realize it. So let's just kind of get started. So suppose that I have two sets. So I have suppose that, and I'm going to have these two sets. So x and y are sets. So x and y are sets. Okay, and I'm going to have throughout kind of this lecture, I'm going to have an example. Keep in mind. So let's say the first one is, so x is going to equal the set that contains the elements dog, cat, and mouse. And then y is just going to contain 1 and 2. Okay, and then the definition of a Cartesian product of x and y, so definition. So the Cartesian product of, and then we have, let me fix that, okay, of, and we have x and y, right? So it's the Cartesian product of two particular sets, so of x and y. Is going to be, so here's in this kind of notation for this, so we have, so when we take x cross y, and then this is going to be defined to equal, right? This is kind of, if you haven't seen this before, maybe I'll kind of say, so this particular notation means defined to equal. Means we're giving a definition by saying that this is equal to set of all. So pairs like this, so they're going to look like x, y, like little x and little y, suggestively, so that we can have, where we're going to require that the first coordinate is in our first set, and the second coordinate is in our second set. Okay, so the key point here, or a key point here, is that this actually has a specific meaning, which is that order matters. Okay, so this is an ordered pair. So this is something called an ordered pair. i.e., a pair where order matters. We can't switch the two. Okay, so when we're looking at this, right, so what do I kind of mean by that? We're not allowed to switch the two and consider it to be the same element of the set, okay? And precisely then when do we consider two like pairs like that to be the same? So it's going to happen precisely when, so we're going to say that these two are the same. So if I have x prime, y prime, that this is going to happen if and only if, so this is this kind of like very mathy language or lingo, so this is for if and only if. Or you could also think of it precisely when. Okay, this happens precisely when we have that x equals x prime, and we also need that y equals y prime. Okay, so both those things need to be true. Okay, so let's look at some examples. We already have kind of set up for an at least one of our examples. So example 1, right? So in our setting over here, we're going to have that x cross y. So for our example over there, we have that x cross y is going to equal the set. So this is going to equal Well, we have to, you have to combine everything in there with everything in here. So we're going to have, we can start with, so we have to have dog and together with 1. And then we have to have dog has to go together with 2. Right, but then now cat has to go together with both 1 and 2. So then we can do cat with 1. And we can do cat with 2. But we're not done yet, right? Now mouse has to go with both 1 and 2. So we can do mouse can go with 1. And we can have mouse can go with 2. And that's it. Now we can close up the set. Okay, so I had to take everything from the first set and put it together with everything from the second set. So that's the first example. Here's another example. This is another one that should be very familiar to you. Okay, so we have, if we want to take, so R2, the Euclidean plane, like we're used to, is actually the Cartesian product of R with R. Right? So this is the Cartesian plane, right? So a point, you can almost think of it as like this one gives me the first copy of R, and this one gives me the second copy of R, right? And then if I have a point here, if I have the point 1, 3, for example, right? This point here, which is my first coordinate is 1 and my second coordinate 3, is not equal to the point where I go 3, 1. Right? These points are not equal, right? So we know this is kind of showing us like order does matter. Okay? So that's something also to kind of remember. Because this is a good example of a Cartesian product, if you're having troubles kind of remembering a little bit of the rules. Like you can remember there that order mattered there. These are not the same point. Okay? So Cartesian products, they show up all over the place. You have 2 sets, and you look at all the ways to take something from the first set and then something from the second set. And you write them as like an ordered pair, so order will actually matter. Okay, so I hope that made some sense. And I will see you in the next lecture.